allowing the blood to flow to the tissues. And if I can get the blood flow to the tissues quicker, this would allow anything I need that broke the opening from this inside of my body to the outside, which is something I don't want to happen, okay? Because if I breach my barrier to the inside world, I'm allowing a lot of things to enter my body. And I want materials that can help me stop that breach and stop any type of foreign particle from entering. So by dilating my blood vessels to that area, I increase the blood flow, I increase materials to the site so that they can help me not only close it, but fight anything that tried to enter. Something else that basophils are going to do, they're going to secrete heparin. Have you ever heard of heparin? How? Kayla?
We use it to stop the blood from clotting.
This is a material that we use to stop the blood from clotting. Of course, being created in a lab, it's literally rat poison. Yeah. But it stops the blood from clotting, allows it to continue to flow, and believe it or not, in our body, being a natural product, we need it. Y'all ever worry about your blood clotting? I do. Because you know why? I'll show my age here. 90210. I know y'all don't know that. Okay. Oh, you did? Oh my goodness. Nuh-uh. No. You did. Okay. Well, then y'all know Luke Perry died yesterday. Okay? He's 1 year younger than me. And how did he die? Stroke. Blood clots in the brain. Yep. So yeah, I kind of think about it now, older I get. So this we actually need, and we need it in ways that we might not think about, Kayla, because I know you're probably associating it with your job and how do they administer that to, like, during surgery or anything?
They don't. Sometimes they might, but it's mainly when we're running blood work, just so that we don't put it on us. We can do without it, but we just use it. It's easier.
Oh, so like when they draw blood,
Yeah,
they have like a little bit that they use?
It has to be drawn up in a syringe before we even pull the blood from the patient so that it doesn't clot.
Cool. Okay. Okay. So I learned something new today. So one of the things that will happen is not only is this needed when it's not a time of the breach from the inside body to the outside, it's also needed at a time just for natural blood flow of the body. The agranulocytes, those two that are left over, these are going to be special. That's the best term that I can give them. Lymphocytes, monocytes. Now remember, all of these cells that are moving in the blood, they are formed in the bone marrow. Now, in the case of our lymphocytes, monocytes, those other three, lifespans are short, okay? It can range anywhere from a couple of hours, couple of days, couple of weeks, okay? But when we get to these two, it's a little different. With lymphocytes, think about this term, lymph. Does anything come to mind when you hear lymph? Think about our lymph nodes, okay? Yes, these cells are playing a part in this immune system that we have, but now these, they're going to get formed, they're going to migrate from the blood to tissues of the lymphatic systems. For example, we might see them go spleen, thymus, okay? They're going to survive for decades. Their number should be second highest in a blood count, normal blood count. They're going to have several different subclasses, which we're going to get to in later chapters. Each one having a different immune function. Our monocytes, those are going to migrate to the tissues from the blood. They'll live a few years. They should be third in number. So in a normal count, neutrophils, lymphocytes, monocytes, eosinophils, basophils. From highest in number to lowest in number. And they all have a norm that will exist. With the monocytes, they do rise in number with inflammation and viral infections. Which one was it that focused mostly on bacteria? Neutros. The neutros. So, if you're sick with a virus, such as a cold, the flu, okay, these are getting produced very quickly so that they can go after that foreign particle that has entered the body. They can and do migrate out of the bloodstream and transform into macrophages, meaning eating. Phage means to eat. So, yes, they're highly phagocytic. That means they want to engulf that foreign particle and kill it. They also are going to act as an antigen presenting cell, an APC. Now, what does that mean? We're going to come back to this, but I'll just tell you real quick what happens. If we get invaded by something, and as you know, like for example, with cold or the flu, one of the things that will happen, temperature will go up, lymph nodes and stuff will swell up, that sort of thing. That is the body's actions for trying to fight what has invaded you. Okay? Now, like I've said before, under normal circumstances, leave the body alone. Drink plenty of fluids, get under the quilt, get out of the quilt, whatever it takes, okay? Sleep, rest, okay? Let the body do its job. It's when things begin to go up for temperature, okay? Usually past 102, okay? You need to start being concerned, okay? Because what the body's doing, it's building these cells to go fight the particle. When it can no longer win the battle. These cells will literally ingest that foreign particle, break it up, put a piece. It'll take a little piece of that foreign particle, push it through its cell membrane, and that cell will move to the closest lymph node. In the lymph node are going to be sitting my lymphocytes. And it will present that foreign particle. And basically what it's doing is asking for help. Does that make sense? It's a really cool, when you get sick and you learn everything that happens with the immune system, it is so cool what your body does. It really is. So we will come back to both of these because they are going to be a part of the immune system. The life history for the leukocytes, if you guys remember, we have that one huge stem cell, the pluripotent stem cell. We have our colony-forming units that get formed. Do you guys remember how that gave rise to? Same thing, okay? Nothing is changing. We see that that big stem cell gives rise to the colonies. We're going to produce them as needed. This is why there's not a lot of them in the blood unless we're sick. So they're basically formed in response to need. We're going to see that we can have cells respond to infections, but also other immune challenges where we, for example, we might need antibodies to get formed. Not just a cell that's going to go up and eat the particle. We may need to form an antibody, and we can do that, which we'll get to in another chapter. So, based upon what is the foreign matter in the body and the cell that we may need to fight it, that's what will be stimulated to produce more cells. Like I was saying, we're going to see these cells formed in the bone marrow, and as we begin to look at some of those cells, like we were saying, some of them lymphocytes, all right, they're going to have to migrate to other tissues. One of the tissues they're going to migrate to, the thymus gland. Because the thymus gland, which was a part of our endocrine system, it will secrete its hormone, thymopoietin, and that cell that got produced in the blood will get exposed to that hormone, and that becomes our T cells. And those T cells are the ones that will migrate, for the most part, to a lymph node, and they'll stay there for decades. B cells are going to be called up for production when T cells need them. It sounds like a tad bit of a complicated process, but in the grand scheme of things, it's very effective in helping the body fight off any type of foreign matter. So we can have some stay in the blood, like think about our neutrophils, okay, eosinophils and so forth, thymus, the lymphocytes. Some will get to the spleen, lymph nodes, the lymph tissue, and ones that tend to go to the lymph tissue are going to have a very long lifespan. Think about this. If it's a T cell that got formed